sa video natin ngayon, we'll try to solve the following problems, pero the same lang yung beam. However, yung tanong lang dito is to find the slope at 1.6 meters and 4 meters from the hinged support. Now, we already have the answers, negative 277.2 for 1.6 meters and 22.5 for 4 meters. Now, to speed things up, gagamitin na lang natin yung mga nakuha natin sa previous videos. Now, diba, alam natin na yung deviation from B with respect to the tangent at A, ito yung value, 260 kNm³ divided by EI. Now, this is important kasi yung hinahanapan natin ng slope, meron kasing 1.6 which is to the left side of the maximum deflection, and then meron ding 4 meters which is to the right side of the location of the maximum deflection. So, magagamit din natin yung slope at the roller support. Now, later na lang natin yan kukunin. So, yung first is to solve natin is the slope at 1.6 meters from the support. Again ha, this is the hinged support. So, from here, let's move 1.6 meters. Perhaps nandito yan. So, 1.6 meters. So, project tayo ng line. Ito yung point na gusto natin. And so, yung slope din, measured from the horizontal, ito na yan. Ito yung slope ng point of interest. Now, this point is point D. Nagamit na pala natin yung D. And so, sabihin na lang natin na this is point E. Yan. And so, yung slope sa E yung hinahanap natin. Now, sir, paano kukunin yung slope sa E? Now again, remember, dito sa area moment method, di ba, kailangan natin ng 2 points. But di ba, isang tip na binigay ko is to consider yung point dito sa supports. Kasi madali lang kasing kunin yung slope if that's one of your points. Now di ba, alam na natin yung slope sa A. That's simply rise over run. Now, alam na natin yung deviation of B with respect to the tangent at A. And so, yung slope at A, again, di ba, nasolve na natin to. We have the deviation of B with respect to A divided by the run, which is 6 meters. Ito yung horizontal distance. And so, copy ko na lang. Ito yung slope at A. So, yung numerical value nito is 360. Now, I will just explain later bakit natin to kailangan. So, balik tayo. Diba, ito yung slope at A. And then we can also draw a tangent line dito sa point E. Now, dito sa point E, yung tangent line natin, since this is to the left side of the maximum deflection, we have a tangent line with a negative slope. Yan. Dito kasi, after the maximum deflection, magbabago na kasi yung slope, yung sign natin. So, let's just extend this one. Diba, ito yung first point, and then this is our second point. Yan. Now, diba, sa concept natin, sa area moment, yung angle between the two tangents, or yung change of slope, diba, ito yan. This is the slope of A. Again ha, ito yung tangent at A. And then, ito naman, this is the tangent at point E. Yan. And so, ito yung slope ng point E with respect sa tangent at A. Or you can just interchange this one, kasi hindi naman yan magmamatter. Kasi this angle is the same as this angle. Now, diba, in our theorem, yung change in slope is the area under the moment diagram. And so, we can actually project this line further. Let's say, nandyan. Now, pwede natin kunin yung value dito, saka dito. We can look at the loads. Or pwede rin tayong gumamit ng ratio and proportion dito sa figure natin. Now, para maiba naman, let's just use ratio and proportion. So, for this triangle, diba, alam natin na this distance is, again, 1.6 meters. So, 1.6 meters. And so, solving the height of the triangle, let's use ratio and proportion. By the way, this whole distance is 6 meters. So, we have 810, which is our height, is to a base of 6 meters. And then, we have the height of the triangle divided by the base of this smaller triangle. So, we have 1.6. And then, solving y, we have 216. So, we have here 216. Or again, you can just look at the loads. We have 135. Patungo dito, let's multiply that by the moment arm, which is 1.6. We can get 216. Now, dito naman, for the spandrel, alam natin na this is to the second degree. And so, yung ratio and proportion natin will be a height of 900 divided by a base of 6 meters. But then, we'll square this one. Now, this is equal to a certain height. And then again, we'll square the base. So, we have 1.6 and then squared. So, 900 over 6 squared equals x over 1.6 and then squared ulit. Solving y, we get 64. So, we have 64. Now, again, yung area na yan, yung total area, yan yung value ng change in slope. So this angle. And so adding the areas, we can get this angle. And so we have the slope of E with respect to A. We have the area of the triangle, which is 1/2, times the base, which is 1.6, multiplied by the height, which is 216. And then for the small spandrel, we have minus, since this is below the 0 line. And then we're gonna use 1/3. Kasi again, di ba, BH over N plus 1. Yung degree nito is 2. So 2 plus 1, magiging 3. Yan. So we have 1/3 times a base of 1.6 times a height of 64. And so solving this, we have 1/2, which is, let's just say 0.5 times 1.6 times 216 minus 1/3 times 1.6 times 64. We get, let's just use this value, 416 over 3. And then this is KNM squared divided by EI. Now, hindi ba ito yung hinahanap natin? Kasi di ba, we're trying to solve the slope at E. Now sir, paano mo yun kukunan? Ito yung approach dito. Dito sa point natin, let's try to draw a horizontal line. So di ba, we have this line. Yan. Now di ba, since this is a horizontal line, parallel yan sa beam natin. Kasi di ba, this is horizontal, and then ito namang nasa taas, yung beam natin, that's also horizontal. So this means that the angle between this horizontal line saka itong tangent at A, di ba, the same lang yan sa slope at A. Now again, if you'll try to look at the figure, we have the slope at A, which is this one. The same lang yan dito. Itong angle na to, this is also the slope at A. Now I hope you would agree. Now again, from the horizontal to the tangent at A, and this is also from the horizontal to the tangent at A. And so that's why the same yung slope dyan, which is the slope at A, which we have already solved. Diba? We got a value of 360. But then, diba, yung slope sa E, itong slope na to, this is from the horizontal with respect to the tangent at E. And so I believe you would also agree that this angle, yung angle na yan, di ba, yan yung slope at E. Again, from the horizontal to the tangent at E, and this is also from the horizontal to the tangent at E. Now to make this clearer, let me just move this. Lagay natin dito. Diba, looking at the figure, we can actually form an equation to solve the slope at E. So we have the slope at A is equal to the slope of E with respect to A plus the slope at E. Again, this angle is equal to the sum of these angles. If you will try to look at the figure. Yan. And so we have here slope at A equals slope of E with respect to A plus the slope of E. But diba, alam na natin yung value dito. We have 360 as the slope of A. And then for the slope of E with respect to A, we have 416 divided by 3. And then plus the slope at E. The slope at E will be equal to 360 minus 416 over 3. And so we have 664 divided by 3. And then this is KNM squared divided by EI. And then this is approximately 221.33. Now, medyo may mali sa solution natin. Let's try to check. Okay. Mali pala yung nandito sa answer key. This is minus 221.33, and then for the slope at 4 meters from the hinge support, we have 186.67. Yan. And so ito na yung sagot natin. Ito yung slope at E, and then dito naman tayo sa slope at 4 meters from the hinge support, which is andito sa point na to. Now, para hindi magulo, let's just actually copy this one, and then tatanggalin na lang natin to. di na natin kailangan yung tangent at A. So, erase natin. Saka ito rin. Now, dito naman tayo sa 4 meters from the hinge support. So, we have this answer, and then this is now our point of interest. Let's say this is 4 meters, and then let's project a line. Yan. Now, notice here that yung point of interest natin is to the right side of the location of the maximum deflection. And so, diba, dito sa maximum deflection, there is a change in slope from a clockwise rotation, dito, magiging counterclockwise. And so, ideally, yung ratio and proportion natin, kukunin natin sa triangle which we can form from this tangent line. Now, we're just gonna extend this. Yan. Let's make it more realistic. Ito yung tangent line natin dito sa point B. And then for our point of interest, this is what we want. Now, let's draw a tangent line at this point. So, we actually have this line. Yan. This is the tangent of B. Now, again, tangent at B. And this is the tangent at, let's say, point F. So, tangent at F. And then again, by theorem, yung masusolve natin na angle, if we'll take the area under the 2 points, point B and point F, we can extend it here. Yang area na yan, yan yung change in slope between point B saka point F. So, this is the slope of B with respect to the tangent at F. And then this angle naman, this is the slope at F. And so, just like earlier, it's helpful to draw a horizontal line dito sa point of interest. So, we have this horizontal line. And then, diba, this is the slope at B from this tangent line. And so since this is horizontal, which is parallel to the beam, then this total angle from this line up to the tangent at B, this is gonna be the slope at B. And so forming our equation, if this is the slope at F, then diba, let's just move this one. Since this is with respect to the horizontal, then from this point up to the tangent at F, this is still the slope of F. And then again, the change in slope between tangent F and tangent B, that's gonna be the slope of B with respect to F, which is also this angle. So forming our equation, we have the slope at B, this one, equals the slope of F plus the slope of B with respect to F. Yan. Now, alam na natin yung slope at B. Again, we have it here. The slope at the roller support, which was solved in the previous video, we have 270. So this is 270 equals the slope of F, and then we're gonna try to solve the slope of B with respect to F. Now, to get this expression, isosolve natin yung area na to. Now, diba, medyo mahirap yung area na yan. But to make things simpler, let's just consider the whole triangle minus this smaller triangle para makuha natin yung remaining area. And so let's just erase this one, and then ito na yung area na gusto natin. Now we're gonna try to solve this height. Yan. Again, this is from the hinge support, we have 4 meters. So copy na lang natin. Let's just actually modify the base. Kasi yung base natin is already 4, and then also here. So mag-change yung y. So now we have 810 over 6 equals y over 4. This gives us 540. So this is 540. And then for the spandrel, we have 900 over 6 squared equals x over 4 squared. We have 400. Now again, itong yellow area is the whole triangle minus this smaller triangle. So we have A1 and A2, and then A1 is, again, the whole triangle, which is 1/2 times base, which is 6 meters, the total base, times a height of 810, and then minus this triangle, we have 1/2 times a base of 4 meters times a height of 540. And so solving A1, we have 1,350. Now solving A2, we have, this is below the zero line. So kailangan negative yung area natin. So we have 1/3 times a base of 6 meters for the whole spandrel times a height of 900. And then we have minus 1/3 times a base of 4 meters. Again, we are subtracting this smaller spandrel, so times 4 times a height of 400. So we have here 1/3 times 6 times 900 minus 1/3 times 4 multiplied by 400, which gives us 3,800 divided by 3. And then again, take note that this is below the zero line, and so our sign here is negative. And so adding both of the areas, we have the slope of B with respect to F. So 1,350 minus this value, we got 250 over 3. Now since we have this, we can now solve the slope of F. So this is plus 250 over 3. Now solving the slope of F, we have 270 minus 250 over 3, we got 560 over 3, which is approximately 186.67. And then this is kn m squared divided by EI. Now again, yung direction nito is counterclockwise. Again, from the beam patungo sa point F, we are moving counterclockwise. Kasi andyan na kasi yan sa right side ng location of the maximum deflection. While for the previous problem, we have a clockwise rotation. From the beam patungo sa point E, this is clockwise. So here we have a clockwise rotation. Again, clockwise for this one, while for the other one, counterclockwise. Now sir, di ba sinabi mo na positive is counterclockwise and the negative is clockwise? But dito, positive yung result. Bakit counterclockwise? Again, gumamit kasi tayo ng ratio and proportion. Kaya kinailangan natin na gamitin yung absolute values. But you have to take note of the figure. Since clockwise yung rotation dito, although we used absolute values, magiging clockwise pa rin yung rotation. Kasi yan naman talaga yung assumption natin dito sa ratio and proportion natin. Now, para holistic talaga yung discussion, meron akong i-discuss na alternative method. Now, this is helpful when your beam is symmetrical and then alam mo yung location of the maximum deflection. But dito, we can still apply the same concept, but yan nga, mahihirapan ka kasi kailangan mong malaman yung location ng maximum deflection. However, since na-solve na natin yung location, let's just actually try to use the concept. Now, ito yung approach. Diba, na-solve natin yung point A, kasi alam na kasi natin yung deviation of B with respect to A. Now, what if hindi mo alam to? Ano yung iba mong pwedeng gamitan? Notice na, let's just erase this one. Notice that the tangent line dito sa maximum deflection, di ba, it's only a straight line. Kasi yung slope dito is equal to 0. And so, what if I will treat this as my first point, and then yung second point ko is itong point E. And so, let me just remove this one. What if ito yung gagamitan natin dalawang points? This one and this one. Di ba, automatic na nating makukuha yung slope at E. Kasi yung slope at E, if you will use the point of maximum deflection, we already have a horizontal line, which is parallel sa beam natin. And so I hope you would agree that this angle from the tangent line of the maximum deflection, this is already equal to the slope at E. Now, diba, yung slope at E, since we have these 2 points, ito saka ito, then the area under these points will already define the change in slope. And so the slope at E is actually equal to the slope of D, this point, with respect to the tangent at E. Now, diba, this is simply the area from point D up to point E. Now, let's just retain this one, but then we'll erase the area kasi magagamit kasi natin to. And then the area from point E to point D, that will be this area. Yan. Now, what if I will treat this as area 1, saka ito, area 2. Now, just like earlier, we can get the area of the whole triangle, and then we'll subtract the smaller triangle. The same with the spandrel. But then, paano natin isosolve yung height nito? Diba, dito sa maximum deflection, alam natin na yung horizontal distance from the left end is 2.876. And so dito sa ratio and proportion, we're gonna use this value. So this is aligned to point D, the location of the maximum deflection. We have a base equal to 2.876. And also here. Now solving Y, we have 388.26, and then for the other one we have, this is 900, and then 6 squared equals x over 2.876 and then squared. We can get 206.78. So here we have 388.26, and then this is 206.78. Now solving A1 and A2, this whole triangle is equal to, we have here A1, the whole triangle is 1/2 times a base of 2.876. Again, ito yung base natin, times a height of 388.26. Or you can just use the area of a trapezoid. Depende na yan sa'yo. And then minus this small triangle, we have 1/2 times a base of 1.6 times a height of 216. Now this gives us 385.52. Now for A2, we have the area of the bigger spandrel minus the area of this small spandrel. So this is 1/3 times a base of 2.876 multiplied by a height of 206.78, this one, minus the area of the smaller spandrel. So we have 1/3 times 1.6, which is our base, times a height of 64. And so solving A2, we have 164.1, and then this is a negative area because again this is below the 0 line. So subtracting the 2, we have 385.52 minus 164.1, we get 221.42, and then this is the slope of E. And so as you can notice, this is the same with our answer earlier, but merong discrepancy due to the rounding off of values. Now, if you will use the exact values dito for the height, saka itong mga base natin, then you will get 221.33 exactly. And so this is the alternative way. Now, this is helpful if you have a beam which is symmetrical. Let's say we have a simply supported beam with a uniform load. Now, diba, alam na natin yung location ng maximum deflection. That's simply at the center. Kasi symmetrical yung beam natin, saka symmetrical din yung loading. Now let's say, you want the slope at this point. Let's say this is 7 meters, and then this is at a point 2 meters from the left end. Now if you want this slope, you can actually consider this as your first point, so that your tangent line will be a horizontal line, since the slope here is 0 at the location of the maximum deflection. And then this is now your second point. Now drawing your second point, you have this one, and then the angle between the two lines, considering the 2 points, let's say this one, this is already the slope at your point of interest. So this is the slope at 2 meters from the left support. And so there's no need to solve extra slopes if you know this method. Now kung meron kang problem sets that have this example, or any case where the loadings are symmetrical for the beam, try to apply this one. And then you will notice that it will save you time. So yan lang muna mga Lodi.